evaluating f prime, and f double prime, let's just review really quick what each thing tells us. F, remember, is the graph. It is the original function. Okay? F prime. If you had to use one word to describe f prime, what would you say? Derivative. Okay? So now choose another word. Slope. Or phrase, slope with the tangent line. What does f prime tell you about f? Like, if I said f prime is positive, then you know that f is increasing or, negative decreasing. Okay, what does f double prime tell you? Tells you about concavity, points of inflection. And last week we did all of that, but we did it pretty much every problem was I give you a function, you take the derivative, you algebraically find the critical numbers, and so on. And we're going to kind of do some more interesting type problems. And a lot of this is actually easier than what we did last week, meaning it's less work. But these are all old AP test questions, so you know that some of it is just a little bit more abstract. Okay, so have you seen a problem yet, like number 1, where you're given a table of all this information or a chart? Have you seen this before? No. Not for me. If you've seen it, it hasn't been for me. But this gives us a lot of information about f, and anytime you think f, just those are the y values, okay? So in particular, this 0 and 1 means that the point 0, 1 is on my graph. And it means that when x is 0, f prime, the first derivative is undefined, f double prime, the second derivative is also undefined. Okay, so we don't know everything about this function, but we know a lot about 0 to 3. Okay, so then we get to this right here on A when it says find the x coordinate. Now, anytime you see that, all it means is you're solving for x. Don't get too caught up on x coordinate. It just means that you're not going to have to plug it back in to find the y value. So you end up doing less work. Okay, so we're trying to find the x coordinate when we have an absolute max or an absolute minimum. Okay, so I'm just curious, does anybody in here think they know, based off of that chart, where the absolute maximum is? You think it's happening at x equals 1? Uh-huh. Okay. What about anybody else?
Actually, 0.
0. I'm gonna write these 3 points down just based off of this information. So out of these 3 points, where is the absolute max? What's the highest point?
0.
At x equals 0. Now, without looking too closely, it could be possible that there are points, though, that go above that. I mean, these are not the only 3 points on the graph. So it's not really clear where our absolute max is, but we could maybe guess that it's happening at x equals 0. Okay. Where do you think the absolute min could be?
X equals 2.
X equals 2. Does it have to be at x equals 2? Now, if you look at this more closely, you may be able to figure out yes or no because of this. But I just want you to see, these are 3 points, but you're really going to have to look in between to figure out everything that else is going on. I really don't think that A is very obvious. It's not obvious to me what the absolute max or min is. Now, if I'm just considering those 3 points, then I can. And can I just consider those 3 points? I mean, let me ask you this. When we were trying to figure out where we had a max or a min, using extreme value theorem, what did we use? How did we use extreme value theorem? Okay, I will remind you that we set our first derivative equal to 0 or when it was undefined, and those were critical numbers. And we used our critical numbers and we used endpoints. Okay, so it seems like that's what's going on here, although I'm hoping that all the critical numbers are included, although there is one endpoint that's not on this chart, and that's 3. So although I don't think it's very obvious, it will for sure be obvious to you by the time we finish this problem, because we're going to graph this. And once you see a graph, you're going to know what the absolute minimum max is. Okay, so I'm going to skip that part for now, and we'll come back to it. All right, now on B it says, over what intervals is the graph of f increasing? justify your answer. I'm actually going to start with the justification. So I'm going to say I have some answer, leave some space, and then what would be my justification using f prime? F prime, you could either say it's positive or is greater than 0. Okay, once you know the justification, the rest of this is really easy because you could just look up here and you could say, okay, f prime is positive between 2 and 3. That's the only time. So that's your answer. I mean, think back to how much work we had to do before to figure out where our function was increasing or decreasing. This is actually a lot less work. It's just weirder. Yeah, it is a lot easier. So some of this is going to be easier. Some of this might be a little bit more difficult, but this part is easy at least. So if I ask you about f decreasing, we're going to start with our justification because, why? F prime is less than 0. So I go and I look in my f prime row, and I have a negative between 0 and 1 and between 1 and 0. Can I just say from 0 to 2? No. Why not? Yeah. At x equals 1, is f prime negative? No. So f is not decreasing. Okay, so we're just using the chart to figure out this. Now we're going to use the chart again. D and E have to do with concavity. What tells us about concavity? Double prime. Okay, so let's write the justification. Because for concave down, f double prime, second derivative, would be less than 0. So again, we're looking for negative, but this time in the f double prime row. So this would be between 1 and 2 and 2 and 3. Is this making sense? Are there any questions? You get out of a lot of number crunching and algebra when you do problems like this. And that's good. This is an old AP test question. I changed it a little bit. But, okay? So then I want you to go ahead and write your answer to E and then check with the neighbor. See if they got the same thing you got. I'm going to encourage you to do it the same way we did it. Start with the justification, then go to the chart to find your answer. Okay. Am I going too fast? Y'all got it? Y'all are all looking at me. What'd you get?
0.
0 to 1. Okay, so far, not too bad. Okay, F says find the x-coordinate for each point of inflection. So we got to think, where do the points of inflection occur? Are we talking F prime, F double prime? Double prime. F double prime being what? 0 or undefined. All right, now we're going to have to be careful here. I have an undefined, a 0, and another undefined, and I don't know what's happening at 3. Okay, one of these is not really a point of inflection. So let me remind you that my graph is only existing between 0 and 3. So can you have a point of inflection at an endpoint? No. So we're actually not going to include that one in my points of inflection. Now, if you missed it there, you would figure it out when you do your graph, because you would have said, hey, I was supposed to have a point of inflection at x equals 0, but it's an endpoint. It's not a point of inflection. All right, now what's my justification? It's equal to 0 or undefined. Okay? So let's now do the graph, and this is going to be a little bit harder for me because I don't want to have to keep scrolling up and down. But remember, we're only going from x equals 0 to x equals 3, and if you notice on this problem, it's broken up into chunks, and they're not overlapping. So tell me, what is happening between x equals 0 and x equals 1? first of all, between, let me back up just a little bit. Let's graph our points, right? That'd be a lot easier to start with. 0, 1, 1, 0, and 2, negative 1. So we're going to get sick of this scrolling. And it would be so nice if I could just draw a line that goes through those. But I know if I have concavity, then I'm not going to have a line. I'm going to have curves. Okay, so tell me again, and I'm going to erase this right here. I want it to be clear. What is happening between 0 and 1? First of all, are the y values going to be positive or negative?
Positive.
Positive. Okay, so I'm going to write a little plus there. Okay. Is f prime positive or negative?
Negative.
Negative. So that meant we were decreasing. We already saw that. And which concave did we have?
Upwards.
Concave up, right? So there's only one way to draw this. First of all, I've got to stay above the x-axis because of the positive. I've got to decrease. Well, that makes sense because it looks like I'm decreasing from point to point. And then the really thing I got to focus on is concave up. Now, I'm going to really encourage you guys to use pencil because this is kind of hard to do sometimes, just to make that look like it's concave up. Notice that I'm exaggerating the concavity. What you don't want to have happen is someone not know whether you were doing concave up or down. Like, you don't want to make it look too much like a line. Exaggerate the concavity if you need to. Okay, so then between 1 and 2, this one had y values that were negative, and this is from the chart. I'm not going to keep scrolling up. And that makes sense, because from 1 to 2, I've got to be below the x-axis. We were still decreasing, right, because f prime was negative. And what was our concavity? Down. So I can't just draw the same thing. I got to be concave down. Well, what this is going to look like is a little bit flatter at first. And if you're having a hard time with your concavity, your little sections of the concave, just think about a circle. And if you split a circle up into like half it vertically and horizontally, you see these little curved parts. These are the 4 ways you can draw concavity. So it's really one of those 4 that you have to choose. All right. What about between 2 and 3? The y values were negative, so I got to stay below. Now, at 3, I may be on the x-axis, but I'm never going to go above it. And so I don't know. So I'm just going to be safe and stay below the x-axis the whole time. It looks like I'm increasing because f prime was positive. What about the concavity? Down. So that's interesting because when I do concavity down, it creates a cusp. So we got to make sure that my chart supports the idea that I have a cusp. Okay, so this, I'm going to go ahead and tell you, we did not make any mistakes, but let's make sure that everything that we've drawn here, it checks out on the chart. First of all, do you see that we have 2 points of inflection? X equals 1, x equals 2, where we change concavity. All right, look what's happening at x equals 1. The first and second derivative were 0. That means that I have a horizontal tangent, I have a flattening out, and I have changing concavity. Okay, that makes sense. But then look at when x equals 2. First and second derivative are undefined. Does it make sense that our first derivative is undefined at a cusp?
Yes.
Yeah, cusps are not differentiable. So all of that helps check it out. If you get a contradiction, it's because you made a mistake. So it's a really easy way to know that you did something wrong. Now, I won't tell you what you did wrong, but it will help you figure that part out. And that's how you do these little graphs like this. So let's practice another one. So turn the page. And on this one, we're not given a chart. Okay, we're given a graph. Now, from now on, when you're given a graph, you cannot assume the graph is the function. So on this one, it says the graph of f prime is sketched below. Normally, they give us the graph of f, and maybe we need to match it to the graph of f prime, but this is the first time they gave us the graph of f prime. So this graph right here is already the slope of the tangent line. So you've got to keep in mind, this is the graph of the derivative. So when we're looking at a, over what interval is f of x decreasing? What you can't do is say, oh, f is decreasing all this way. F is decreasing from 1 to 2.5. No, f prime is decreasing. But if this says f of x is decreasing, it's a little bit more complicated. But I'm going to tell you something that's going to make this easier. Write your justification first. So again, what's our justification for why f is decreasing? Because f prime is negative or less than 0. So what you're going to do here is you're going to look, and when we're talking f prime is positive or negative, I'm saying positive is up top, negative is down below. We're not talking about slope. The slope part is done for you. And so this little piece right here, negative 2 to 0, f prime is negative. And then also from 2 to 3, f prime is negative. Do you see how it'd be easy to get mixed up here? You have to know that they're talking about the derivative here. This is why when you start with the justification, though, it's easier. Okay, start with your justification, go to the graph, and figure out how to find your information. So B says, over what interval is f of x increasing? Again, I'm not talking about this graph increasing. So start with your justification. Here, f prime would be positive. And again, f prime being positive is everything up here on the top. I'm going to go ahead and put arrows in just so you can see that this is a continuous graph that goes on forever. And it tells us in the directions that the domain is all real numbers. So that's how we would know that. So I actually have 3 pieces now. I'm going to have to start way over here. Negative infinity to negative 2. That would be this little arm right here. Then we have this little section in the middle. 0 to 2. And then I need to union that with the last piece. 3 to infinity. Okay, before I move on, I want to ask you, do you think there could ever be a time where your answers for A and B overlap? Meaning intervals are in both A and B. Could an interval be increasing and decreasing? No. No. Not unless there's more than one derivative, which is not the case. So that's a good way to check it as well. Okay, these should be exclusive. They should not have any overlapping. All right, concave down. What's our justification? Yeah, f double prime is negative. Now, this isn't the graph of f double prime, and it may not be obvious to you what f double prime looks like. You could draw f double prime. We know how to graph the derivative. You're just the double second derivative would be derivative of the derivative. You could do it that way. What I want you to though write in parentheses is how this is, if f double prime is negative, what does that tell us about just plain old f prime? F prime is decreasing. What's the slope when something's decreasing? Negative. So essentially what we're saying here is the slope of the slope. Okay, but that's confusing. This is why we have names like first derivative, second derivative. So what we're really looking for here is when f prime is decreasing. Okay, this is, before we weren't really paying attention to when f prime is decreasing, but for concavity, we are. And so that looks like negative infinity to negative 2. And then what would be the next piece of that? 1, 2.5. Yeah, we're going to have to kind of guess here. 2.5. It's not exactly accurate, but we can say it has to be pretty close to 2.5. Okay. It doesn't ask about concave up, but do y'all feel like you could find that if you needed to? What would you look for when f prime is increasing? Okay, which would be all the other intervals. All right, then we get to this whole idea of relative max. Again, what you might be tempted to do is say, hey, there's the relative max right there. Well, that's a relative max of f prime, but not of f. So we start with the justification. And again, here it says values of x. So we don't have to find the y value. It's good because I have no way of finding it anyway. So x equals something because, all right, we have to use the derivative. So let's think of a way we can use the first derivative to justify a relative max. Yeah, specifically f prime changes positive to negative. And if you think about just a plain old max, as you go up towards the max, the slope of the tangent, the first derivative is positive, and then once you come back down, that changes to negative. So again, see how we have our plus and our minus here? I wrote that so I knew we were going to come back to it. So when is f prime changing from positive to negative?
-2.
At -2. And where else?
0.
Okay, at 0, it's doing something similar but opposite. At 0, the graph is changing from negative to positive. Remember, you always got to read this left to right. So what's the other value? Positive 2. These are the two places where f prime changes from positive to negative as you go from left to right. So I need to, we could say even plus minus 2. That would be okay. Okay, so I want you to do part E on your own. Again, check with a neighbor when you're done. If you're not sure what to write here, at least be thinking, what should my justification be? Okay, what do we get? X equals 0 and 3. And you can write it like this is fine, but don't put parentheses around it. Parentheses imply that you're either talking about a point or an interval, and I'm just talking about a set. So you could write x equals 0, x equals 3. You could write it with the curly braces. This is fine too. And the reason is because f prime is changing from negative to positive. Okay, so it's the same concepts we did last week, but kind of different types of problems. So S says, what value of x does f of x have a point of inflection? So point of inflection are where we change concavity. So what's my justification? I'm going to start it. F double prime should be what? 0. That doesn't help me a whole lot with this graph. It's a good justification, but how does that relate back to f prime?
There's
A relative min or max, and it's not happening in this problem, but could we be decreasing, level out, and decrease more? Was that a point of inflection? Sure. So I'm not going to say relative extreme in here, although that would be totally acceptable because that's the only thing that's happening. I'm going to say f prime has horizontal tangents. Remember that this is kind of brings it back to what we did, and this encompasses relative max, relative min, and that whole point of inflection in the middle of it decreasing or increasing. Okay, so where is that happening? Where does f prime, this graph, have extrema or horizontal tangents? -1, 1, and 2.5. Okay, these points right here. There's a lot going on this graph. Agreed? All right. Do y'all think this one was easier or harder than the chart one? Harder. Most people do, because it's analyzing a picture, but not the picture you really want. Okay, now we're going to have to draw a picture of our original. And then this should really, we're going to use all of our information. Now, because my domain of my derivative was all real numbers, it stands to show that this derivative should also be all real numbers. Now, we didn't have any points, so they actually told us just to go ahead and start with -3, 1. And there's a lot of different ways to kind of organize your information, but what I'm going to ask you guys to do is to, at least on this first one, write it out the way I'm going to write it out, and then you can decide what's easiest for you. It's just too many things to just say, oh, the graph looks like that. It's not that obvious. Okay, so first, let's talk about increasing or decreasing. So, f, this is the graph I'm graphing right now, f of x. Did f of x start out increasing or decreasing? Okay, and when did it stop? Okay, so this is where I'm going to have to scroll a lot. So all I'm doing, don't look at the graph. We're done with this. Look right here. We're increasing from -infinity to -2, 0 to 2, and 3 to infinity. So this is what I'm going to write here. I'm going to write increasing, and then what was it? 0 to 2, increasing, and then was it 3 to infinity? Yeah. Increasing. And likewise, and decreasing on the other intervals. Okay, I'm not going to be able to do this the way I did the other one. The other one was really nice and neat. You had chunks. Okay, and this is in chunks, but my concavity is going to be in different chunks. So again, I'll come back to that, but look at my concave down. I'm concave down from -infinity to -2 and from 1 to 2.5. Okay, so concave down. I feel like I did that. Sorry. Yeah, this should be -1 right here. Did any of y'all think I was being weird when I wrote that? Yeah. Well, I'll tell you how I knew how I caught it down. So just everybody watching this video. Mistake. Let's see. Okay. Was because these shouldn't be starting. These should really be happening at the same time. Critical points and points of inflection are typically the same. They definitely can be, but they're not always the same. That was a red flag for me. And so this started out being concave down. Okay, we also had concave down from 1 to 2.5. And now I'm writing the words. You may want to do a picture with the lines going up or down like how we did on the sign chart or the U's, and I don't know. I'm going to let that be for you because this is just work to help you see what's happening. Now, we also have some values, which I'm going to make sure stay right here. I'm not going to write them because I feel like if we write anything else on this graph, it's going to get confusing. But all of this stuff should be happening. We should still have a relative maximum at these two values, mins here and points of inflection. Okay, so I'm going to start back over. -3, 1 is my first point. Okay, as I leave -3 and move on to -2, this right here, it's real clear, increasing concave down. So this is again where I really encourage you to use a pencil because even that, I don't really like that I did right there. It looks too straight. So I'm going to kind of do something like that. Now, right here at -2, I'm still concave down, but I'm going to change from increasing to decreasing. Now, does that match up with the fact that I have a maximum at -2? Yes. Okay, and those are the things you can check. You can always clean it up after the fact. Make it nice and smooth. All right, now at x equals -1. I have no idea where the y value should be, and I didn't know how tall this should be. It's just a sketch. But I'm still going to be decreasing, but I'm going to change my concavity. So I'm just going to go ahead and make a point, and I'm going to go ahead and make my concavity look more up. What's happening at x equals 0? At x equals 0, I should have a min And that makes sense. Well, it seemed like I was kind of rounding out to it. Now I'm going to increase, still concave up. I don't really know how far up I need to go, but at some point, I need to make a point because I'm going to change my concavity to down. Again, I already messed up again. This is hard to do on this air slate. Make your concavity exaggerated if you need to. Looks like I have another max, a little relative max happening at 2. I knew that was going to happen. Still concave down. At 2.5, it looks like I was supposed to change my concavity. And then at 3, I was supposed to have a mid, so I messed up. And I'm kind of showing it to y'all this way because I want you to see this is not easy. And I'm not going to pretend like it is. I need to make this where I have a mid happening at x equals 3 and a point of inflection at 2.5. Okay, it looks like I changed to concave up. I'm going to continue to be concave up and increasing. Down here, I'm going to go ahead and put an arrow at the end. These graphs right here are going to prove to be the hardest ones for y'all. Because I know because they're hard for me. And I have to kind of go back and change it a little bit. All right?